go do crazy things. All right. Okay. Yes. It is on Canvas. I don't have any extra copies, but it's on Canvas. So just do it on paper. Yes, I've already cut the recorder on. Okay, so if we want to take the derivative of this, it's probably best to think of it as kx to the 1/2 minus natural log of x. K is a positive constant. So we're treating it like it's a number, like it's 2 or 7 or 15. So it is not a variable. We do not do product rule here because K is a constant. So we would just do 1/2 K x to the negative 1/2 minus natural log of x. What's its derivative? 1 over x. There's 1 point on this. We can do it, right? Right here. Second point is the second derivative. Okay? Don't simplify here. It's going to make it harder to take the derivative. The only thing you might want to do is think about this as 1/2 k x to the negative 1/2 minus x to the negative 1. So, second derivative, we'll have negative 1/4 k x to the negative 3/2 plus x to the negative 2. All I ask for here is first derivative and second derivative. Don't even try to simplify it. Okay, so like we could try to move stuff around, but it's all it's asking for here. So if we need to simplify it later, we can do that on the next part. But I would just stop here on this. Okay, so we all right on 1? There's 2 points we can get. Nobody's making a 0 this time. If it shows up, if it's this one, it might be 2. Okay. All right. So, for what value of the constant k does f have a critical point at x equals 1? For this value of k, determine whether f has a relative minimum, relative maximum, or neither at x equals 1. Okay. All right, so we're going to take that. Right now, we don't care about the second derivative for this, right? Critical points is first derivative, so this is only that first derivative. And it will help you at this point to simplify a little bit. So you've got 1/2 k x to the negative 1/2 minus 1 over x. So I would do this. I would do k over 2 square root of x minus 1 over x. It's just going to be a little easier to find critical points if you have this like as a common denominator. So if I want to put these together, I need common denominators. So I would multiply this part by x, and I'd multiply this by 2 square root of x. You don't have to. You could solve this a different way. Yeah, I think on this one it won't make a difference. The denominator doesn't actually equal 0, but so if you solved it a different way but still get the same answer, that'd probably be okay. So we end up with k times x minus 2 square root of x over 2x square root of x. And you're going to set the numerator equal to 0 and the denominator equal to 0. So kx minus 2 square root of x equals 0, and 2x square root of x equals 0. Now, I could actually try to solve this part here, I would get like 2x equals 0 and the square root of x equals 0, which is just going to give me x equals 0 for both of these. But at the very beginning, it told us x is greater than 0. So 0 is not going to be a critical point for this because it's out of the domain. So that part doesn't actually give us an answer. Now, the second one I can't solve because it's got a k and an x. But I want there to be a critical point where x equals 1. So what could I do? Plug in 1 for your x. So k times 1 minus 2 square root of 1 equals 0. So k minus 2 equals 0. So k equals 2. It's not in the domain that they give you. And even if it was, they've asked you for k, so since it doesn't have anything to do with k, it still wouldn't be part of your answer. Okay, so I'm going to take k and plug it into my equation that I had right here. So my derivative, if I take 2 and plug it in here for my k, f prime of x now equals 2x minus 2 square root of x over 2x square root of x. And so, what was the critical point again? It was 1. My k value was 2, but the critical point is at 1. So, all I have to do here is for my rule here, I'm just going to see what happens at 1. So, and I know that I can't have anything lower than 0, so I can't have negative numbers here. So, 2x square root of x, if I'm plugging in a positive number, it has to give me a positive number, right? So, it is not going to change signs. It's only the numerator I'm really looking at that's going to change signs. If you make your chart 2x minus 2 square root of x, 2x square root of x, if you do the chart, these are both positive. So it actually is only the numerator that matters. So if I plug in something between 0 and 1, like 1/2, 2, actually, let's not plug in 1/2. Because if 1/2 is fine, but I got to take the square root of it, and this is not calculator active. So let's do 1/4. So 2 times 1/4 minus 2 square root of 1/4 is going to be 1/2 minus 2 times 1/2. It told us at the very beginning that x has to be greater than 0, so we don't want to use any numbers less than 0. So we get minus 1, so we get negative 1/2, so we get a negative here, which means we'll have a negative for our derivative. And then if we plug in a number bigger than 1, what do you guys want to try? Do we really want to try 2? We don't want to try 2 for the same reason we didn't do 1/2. You got to take the square root of it. So 4 is better. 2 times 4 minus 2 root 4. So we get 8 minus 2 times 2. So 8 minus 4. That's positive. So we get a positive over here. And so we do have to summarize here. We would say for k equals 2, f has a, what do we have at 1? Relative minimum at x equals 1 because f prime of x switches from negative to positive. Everybody with me here? Alrighty, the last part. Okay. For a certain value of the constant k, the graph of f has a point of inflection on the x-axis. Find this value of k. So, if I've got point of inflection, now what am I talking about? Not derivative equal to 0, but second derivative equal to, okay. We want to know where the second derivative is 0, and it says a point of inflection on the x-axis. On the x-axis, so points on the x-axis, what are your y 0? So on x-axis, you don't have to write this, but you got to know this, y equals 0. So that piece of information is going to be needed eventually. So, alright, so, let me think here for a second. Okay, so, if I know I got a point of inflection, I know my second derivative, which was negative 1/4 k x to the negative 3/2 plus x to the negative 2. I know that has to equal 0. So, the problem with this is I don't have any, I've got a k and an x, and I can't replace k or x with anything. Because I know at the x-axis, y equals 0, but I don't have a y to plug in for it. The f double prime is not your y coordinate, right? So I don't have a y in here I can plug into. So I can't get rid of that k or the x as this is right now. So let's think about this on the y-axis. On the y-axis, on the x-axis, y equals 0. So that means the original equation, which was y, or f of x, I'm going to put a y instead, equals k square root of x minus natural log of x. That means that that y has to equal 0 in the original equation. Both of these pieces have to be true. So, if both of them have to be true, then I can do some substitution here. I can solve one of them for k or x and plug it into the other one. On the right hand, so if I move natural log over, I got natural log of x equals k square root of x. And I can divide both sides by square root of x. So k equals natural log of x over square root of x. Okay. So I could plug it into the other one, but just because I've done this problem and I know that that's not as easy, the other option we could have is we could solve them both for k and then set them equal to each other, which actually ends up being a little bit easier to do here, or I think. Many years of teaching math. Yeah. You can still do it that way. So you could still, I mean, it would work that way. I'm just not sure how difficult it would be. One thing I do know is this is a mess right here with all these negative exponents. So the first thing I would do over here, even if I was going to plug something in, is I would make this negative k over 4 times the square root of x cubed plus 1 over x squared equals 0. So solving that for k is actually not quite as bad as it seems. You could plug the k in. I mean, yeah, I think solving for k is easier. So if you move all of this over to the other side, it's going to make that k positive. So you got 1 over x squared equals k over 4 square root of x cubed. And then you're trying to get that k right there by itself, so you're going to multiply both sides by 4 square root of x cubed. And that is going to give you k equals 4 square root of x cubed over x squared. Hold on. Okay, so actually I'm going to do this right here. It's going to make it a little bit better. Yeah. Or what? I did a little bit different on the, let's keep on. So now I can set both of these equal to each other. Yeah, it's in the denominator, so if you multiply over here, it cancels because you got one in top and bottom, and if you multiply over here, it's going to end up in the top. Yeah. Well, it's an ugly number, but yes. All right, so if you cross multiply, you got x squared, natural log of x, equals 4. Now, what are we going to get? Let's think about this square root of x cubed times square root of x. That's like x to the 3 halves times x to the 1 half. X squared. So now you can divide off your x squared. The square root of x cubed is x to the 3 halves. X to the 3 halves times x to the 1 half, which is what you're doing when you cross multiply here. It's going to be x squared. Because I want to. So now we're down to natural log of x equals 4. E to both sides. Okay, I'm stopping. Alright. Alright. Are we okay? Let's back up a second. Okay, so we solved this one for k. We solved this one for k. We set them equal to each other. Are you guys with me there?
So why is it still being divided by x squared?
Yeah. So I cross multiply, so I multiply natural log of x times x squared. So that gives me this right here. Then I cross multiply this way, which means I'm doing 4 square root of x cubed times square root of x. Maybe this is a better way for you to think of it. Well, I mean, so yeah. Another way you could think about this is 4 times square root of x to the 4th, which is 4 times x squared. Or you can think of it as fractional exponents, 3 halves and 1 half, and you add those together, and that gives you 2. So when I cross multiply here, I get 4x squared. So I'm at this point, x squared, natural log of x, equals 4x squared. Okay? I can divide off the x squareds and they'll cancel off both sides. Okay? That leaves me over here with, I'm going to rewrite this just so you can see what I'm doing. So that leaves me with natural log of x equals 4. We're almost there. I need to solve for x. How do I get rid of natural log? E to the power, e to the power, cancels here. X equals e to the 4th. I overestimated your problem-solving abilities. Yes. It took us 20 with me in explaining.